In this video, I want to have a look at our second type of sequences called geometric sequences. So a geometric sequence is also sometimes known as a geometric progression. So the shortening for that is GP. And it's when the sequence has the ratio of successive terms as a constant. So that means that we're multiplying by the same thing the whole way through to get from one term to the next. So for example, if we started with something like 6, if we times that by 2, we'd get 12. Times it by 2 again, we'd get 24. Times by 2 again, we'd get 48. And if we keep multiplying by 2 each time, because we're multiplying by the same thing, the ratio is constant. So that is going to be a geometric sequence. We could also, for example, we could times by a fraction. So if we started with like 400, for example, we could times by a half. So we'd have 200 and then 100 and then 50. Even though it's going down, we're still multiplying by the same thing. We're multiplying by half each time, so it's still a geometric sequence. So to put that more formally, it's a geometric sequence if we take any term in the sequence, divide it by the term directly before it, and no matter where we do that in the sequence, we're always going to get the same number. So that number, we're going to use the letter R, and it stands for our common ratio. So we want to come up with a formula of how we can write the nth term of a sequence. So again, we're going to use the letter A to represent the first term in our sequence. So we'd have T1 is equal to A. Now to get to T2, we take that first term and we'd multiply it by our common ratio. To get to our third term, we'd take this one, so we'd have our A times R, and we'd multiply by R again, so that would make this an R squared. To get to our fourth term, we'd take our third term, so we'd have A times R squared. We'd multiply it by R again, so we'd have R cubed. So you can see the pattern that's showing up. So if we have our nth term, we're going to take A, our first term, and we're going to multiply it by our common ratio, n minus 1 times. So when it was a 4, it was a 3. When it was a 3, the power was a 2. So it's going to be A times R to the power of n minus 1. So let's have a look at a few examples. Our first example asks us to test whether 5, 15, 45, 135 is a geometric sequence. So to do that, we're going to take our second term, we're going to divide it by our first term. So we'd have 15 divided by 5, which we know would simplify down to 3. So we're hoping that this is going to be our common ratio. If this is a geometric sequence, any term that we pick and do this with, we should also get 3. So if we took the third term and divided by the second term, we'd have 45 divided by 15, which is also 3. And just for good measure, we could do the last one as well. So we could do term 4 divided by term 3. And that would be 135 divided by 45, which is also 3. So therefore, yes, it is a geometric sequence because that ratio is exactly the same in every case. So our second example asks us to write down the first 3 terms and the 6th term of the GP with the first term 2 and a common ratio of R. So if A is 2, that means that T1 is 2. Our common ratio is 5, so that means term 2 would be 2 times 5, which is 10. Term 3 would be this one times 5, so we'd have 50. And we could keep going and find all the terms up to our 6th term. The only problem with that is that if we wanted something higher than the 6th term, it's pretty painful to go through that process. So let's write a formula for the nth term instead. So we have Tn is going to be 2, because that's our A, times 5 to the power of n minus 1, which means that if we want our 6th term, we're going to have 2 times 5 to the power of 5. And if we pop that in our calculators, we'll end up with 6,250 as our 6th term in that sequence. Our third example asks us to write a formula for nth term of the geometric series 240 minus 120, 60 minus 30, and so on. So the 2 things we need are our first term, which is just the 240. We also need our common ratio. So to find that, I'm going to take T2 divided by T1. You could pick any pair in there as long as they're consecutive terms. So we're going to have minus 120 over 240, which will give us minus a half as our common ratio. So that means that our nth term is going to be given by 240 times minus a half to the power of n minus 1. We could also write that with a decimal instead, so we could write our nth term is 240 times minus 0.5 to the power of n minus 1 as well. Our last example tells us that the first term of a GP is 4 and the sixth term is 972, and we're asked to find the common ratio. So the first term is 4, that means that A is 4, and we know that the sixth term is 972. Now we also know that to find the sixth term, in our formula we'd have A times R to the power of n minus 1. So that would be, in this case, 4, because A was 4. We'd have 4 times R to the power of 5. So if the sixth term is 972, and it also has to come from this formula, that means that 4 times R to the power of 5 has to be equal to 972. So if I divide both sides by 4, I'd end up with R to the power of 5 is equal to 243. And then if we want to get that R on its own, we're going to take the fifth root of 243, which is going to give me a common ratio of 3. So that's an introduction to geometric sequences.